Excellent. Okay, so this is Let's Learn Git. We're at MidCamp 2015, hashtag MidCamp, also MadCamp, sorry, I forgot to include that one. My name is Alina McKenzie. I work here at University of Illinois at Chicago. And on Drupal.org or IRC, you'll find me with the username alimac. I'm not particularly creative there. So I want to begin by asking you to think about storytelling. Humans love to tell stories. We tell stories full of morals. You can think of that as best practices. And also, I want to ask you to think about your projects as stories and the stories of your projects. So, version control, why do we use it? One, we want to know what changes have taken place in our code or in our files. Two, we want to get back to a safer place when we make mistakes. And three, we also want to tell a story about our project and code. So this is really writing stories about our projects with Git. So the first thing that I want to tell you about Git is that it's distributed and not centralized. And what that means is that in a centralized system, you would have a central server that would have all the versions of your project. And what you would do is check out individual files on your computer. And that way, you only have the latest version of the files on your computer. Now, if that central server goes away, you're left with the latest version. But you lose the history, the story of your project. Git is distributed. That means that when you check out a Git repository, you get the whole project, you get its history. So you can go to the beginning, very beginning of a project's history. I also want to mention that there are hosting companies for Git repositories. So this is where you can host your projects. GitHub, Bitbucket, and GitLab are very popular. You can also run your own server. GitLab also allows you to download and run your own server if you don't want to use a hosted service. So command line or apps. I will show you how to interact with Git via command line. But I know that not everyone is especially comfortable with commands. So you can also use graphical user interfaces for Git. There are apps such as SourceTree, GitHub for Windows and Mac, and SmartGit, which you can use to interact with Git. Because in a command line environment, you interact by issuing one command at a time. Now, in an app like SourceTree, you have a better sort of at-a-glance view of your project. So this is up to you how you prefer to learn. But here, I'm going to talk about commands. So first step, after we download Git, is to configure it. There's 3 levels of scope. System, which is not often used. User, which is referred to as global scope. And directory, which is the local scope. So you can have settings that are global for all your projects, but you can also set certain settings locally. For example, you might want to use a different email address for your work project and then for your personal project. So let's do that. Let's set our name and email. To do that, we use the git config command. And here I'm setting it globally to my name and email address. And I can also use git config-l to show that configuration. I'm going to breeze through commands and make these slides available afterwards, because this is such a short session. Originally, I was supposed to do 15 minutes, not 20. So I'm going to leave these 3 very useful configurations. Color.ui is set to true, which will give you color output of Git, and you can change those colors if you like. You can also set a global exclude file. So, for example, I work on a Mac, and Mac has this annoying tendency to leave ds_store files everywhere. I can tell Git to always ignore those files. Also, this last one is core.whitespace. You can have Git show you a trailing space in your code, which is very useful if you care about that stuff. So, our setting for our story, we have a local repository or a project folder on my computer, and there's a remote repository on GitHub or Bitbucket, and that repository is something that multiple people can contribute to. So, think of your projects. I have an example project here called Packing List, and in it, it's basically a folder named Packing List, a README file, And the contents of the README file right now is just a heading, packing list, and packing list for trips as a description. So that's fairly simple. Okay, so to get started with Git, we're going to create a repository. So we're going to cd into the packing list directory and run the command git init. And that initializes an empty Git repository. This will create a hidden folder, .git. And this is where Git stores all of your history, all of your project snapshots. If you delete this history, it's like deleting the history of your project. You're still left with the files, but that's gone. So let me tell you about the phases that your files in the project will go through. At first, your files are untracked. Git sees them, a file, but it doesn't really know anything about it. The second stage, or phase, is when Git is tracking the file. It knows about the file, and it tracks its changes. Now, as we work, we kind of touch and edit a lot of files. But what we want to do is have a special place where we can put the changes that are ready to be committed and saved and written to history in a separate place. And that's called staging. So we sort of prepare those files and changes for commit. Then we commit the changes to history. This is writing our story in our commit. Finally, and this is all happening locally, finally we push our commits to the remote repository. So, as we go through these phases, we have 3 sidekicks that can help us answer questions like, where am I? What is going on? And what did I just do? The first sidekick is status. Status answers the question of where am I? Git status, an example of this command is shown here. It tells us that we're on the branch master. This is our initial commit. We have an untracked file called readme.md, and Git even hopefully tells us that to track it, we should use git add file command. So that's great. Now let's do that. Let's do git add readme.md and run git status again. And now we see that these changes are ready to be committed. The first add will always both start tracking the file and also stage it for a commit. So you will use that command, git add, quite a lot. So, let's back out of that. So let's make a few more changes to the readme.md file. Let's add an actual list. I'm going to put my laptop, skirt with pockets, and toothbrush to the list of things I take on trips. And now, let's do another git status. Okay, so what we see here is that there are changes that are staged to be committed, but there are also changes that are not staged for commit. So your file looks the way it does shown here, but Git can separate that out and stage only certain changes for a commit while leaving the other changes still not staged. So this brings us to our second sidekick, which is diff. Diff tells us what is going on. When we run git diff, it will tell me that there have been changes that happened to the readme.md file in between the time that it was staged and now. So on the left-hand side, you will see little plus signs that say these lines have been added to the file. So let's make some history. To commit, to actually write something to history, we're going to use the command git commit, and here we're going to use the shorthand -m with the message, initial commit, and that's going to be our very initial commit. And this brings us to our third sidekick, which is git log. It tells us what just happened or what has happened overall in the history of the project. Right now, we only have one commit. The commit is identified by a long string of numbers and letters. It's called a hash. And it's unique per project, but usually just the first 7 or 8 characters are enough to make it unique. And this will be useful later. It also has the author information that we set before, the date, and the message. So let's talk about a little bit about commits. Commits are set a set of related and reversible changes that function together as a unit of work. Now you define what that unit of work is. So you basically set the parameters, whether it's an entire feature or just a small subset of changes. But because we're human, we always work a little bit less precisely than in units of work. So we will sometimes make lots of unrelated little changes to our projects. This is where git add-p comes in, and this helps us to stage the changes in parts. Let's see how that works. Let me make a few more adjustments to my readme.md file and add some headings, technology, clothes, and toiletries. And now I run git add-p. So this is asking me whether I want to stage this hunk or chunk, and gives me options to say yes, no, quit, I don't know, I don't know, I don't know, split, or edit, or a question mark to ask for help. Well, I just want to commit, or I just want to stage the first one, so I'm going to split it. Now Git splits this entire hunk into 3 smaller hunks, and I can stage just the first one. Finally, the commit message. When you run git commit without the -m, it actually opens up a text editor, and it will allow you to write lots of text. The convention is to use a short descriptive subject line, kind of like in an email, and then put a longer description of what you're doing, why are you doing this, and maybe reference a ticket or an issue number. And finally, we can push. First, we have to add a remote repository. Right here, I'm using Git bucket. I created a repository in my account. I'm setting the remote repository, and I'm calling it origin. This is a convention. You can call your remote repository anything. So, and then you're pushing it to the remote repository with git push -u origin master. This is to keep tracking the branch. Okay, undoing things. We always make mistakes. We always need to do undo. And Git allows us to undo in several ways. We can unstage a file with git reset head and then the file name, or git reset-p. Git reset-p is analogous to git add-p. It's interactive, so you can take out changes interactively, which is great. You can also undo all changes to a file with git checkout --read. Okay, but what if you already committed but not yet pushed? Well, you can update the last commit always. It's really easy. Just stage or unstage files as you would normally do, and then do git commit --amend, which will amend the very last commit. You can also undo the last commit if you want with git reset --soft head, or git reset head with a ~1 to also unstage. But if you want to undo more than one commit, you can just do that same command, but after the tilde, put the number of commits that you want to go back. And if you want to undo a specific commit that's somewhere in the middle, you can do git revert and then specify the hash of that commit. So this is where that long string of numbers and letters comes in. You can specify just seven of them. And what this will do is prompt you to do another commit where you will explain why are you reverting this particular change. If you've pushed to a remote repository, don't do it. That will rewrite history. That will mess things up for other contributors. But if you really have to, and you are the only contributor, like this is your project, then you can do that. It's called git push --force. Again, don't do it if you're working with other people, because that will make their lives miserable. Branching is an excellent feature of Git. It's a cheap way to create copies of your project. Instead of having several directories, you can have one directory, but Git keeps multiple copies in it. It's a bit mind-blowing to think about at first, but it's really great. And it's easy to merge these branches. So how do we create a branch? We can use the command git branch testing. And here what we see is commits. except these arrows pointing left are actually kind of counterintuitive because we think of our project as going forward. What these arrows indicate are parents. So our last commit, this F30AB, this is where our master branch is, and head indicates where we currently are. So we are currently on the master branch, and we just created a second branch, which also points to the same commit. Great. Not very exciting so far. So let's switch to that branch with Git Checkout testing, and now we see that head pointer has moved towards testing. Still not very exciting. Okay, now let's make some commits to the testing branch. And now we see that while master remains at F30AB, we have moved forward. So we can switch back to master branch with Git Checkout master. And now we return to the snapshot of our project as it was at that commit. This is really great. All right, so how do we merge these branches that we make? Well, we can do that with the Git Checkout command and Git merge command. So first we check out the branch that we want to merge into, and then we run the command git merge the branch that we want to merge, which is testing. So we're going to run into two situations. First is the easy one, where master has not advanced at all, and we can just fast forward it to where we are right now. But there's a more difficult situation is where master has diverged, and there's another commit. So what do we do now? What Git does, it will do for you automatically, is that it would look for the most common ancestor, and then the endpoints of your two branches, and create a merge commit automatically. And now the two branches have been merged. And I don't know why both of these are C5 commits. I think that one should be C6, because it's the merge commit. Rebasing is another way of merging your project, but without that merge commit, without that one commit to tie the two branches together. Rebasing is, you gotta watch out for it because it does rewrite history, so don't rebase things that have been already pushed. It rewrites history in the way that it changes the commit hashes. So let's look back at our divergent branches. We have an experiment branch, which is at commit number 4, and a master branch, which is at commit number 3. And what we're going to do now is Git Checkout experiment, so the branch that we want to eventually merge into master. And we're going to run the command git rebase master. What that does is it takes our changes. So C4 is the experiment, the last commit on the experiment branch. So what it does is it lifts all of the changes that have been made on the experiment branch temporarily, holds it in space, advances our branch to where master is, and then stacks those changes on top. So now our branch looks just like master, except it's a little bit ahead. This makes it easy to do a fast forward merge afterwards, just because we can do git checkout master and then git merge experiment very easily. But you'll see that this last commit is C4 prime instead of C4. It's because the hash has been changed. Okay, this was really smooth so far, but what if there's conflict? What if a file has been modified in the same place in two different branches? Well, when that happens, Git will stop the activity, whether it's a merge or rebase. It will list the files that have conflicts for you, and now it's your turn to resolve them. So you'll go into those files and resolve the conflicts, and afterwards, add them to stage the files to continue the merge or the rebase. Git puts conflict markers in the files to let you know what exactly is the conflict. it will mark them with 7 less than signs and then the name of the branch. And in the middle, there's going to be like 7 equal signs, and then the content from the other branch, followed by 7 greater than signs and the branch name. So here we have a file which has a question: how many planets are there in the solar system? And one branch says 8, and the other says 9. Well, Git's kind of like, what do we do? So to fix the conflict, we replace the text between the markers with our resolution, and then delete the markers. So here's how the resolution would look like. We just delete the markers and leave whatever it is that is the correct content. And then we do git add file to mark the conflict as resolved and to continue the merge or the rebase. So I have 2 resources that I want to point out to you for learning Git, which are great. I really recommend the Atlassian tutorials. And there's also a free ebook on the Git website where you can download Git. It's long, it's super detailed. It has a chapter that basically looks at Git internals. It's a great book to take on a plane. By the time you reach your destination, you will learn a lot about Git. I also want to encourage you to stop by on the Sunday Sprint if you want to practice or experiment with Git and Drupal. It's going to be right here at UIC in the SCE Tower in room 605. And finally, please give me some feedback on my session here at bit.ly /midcamp /git. Also, I was told that since my session got cut short, we can have a BOF in the main room. So if you want to ask me some questions or help you get set up with Git, just come in, talk to me, find me. Thank you.
What is the difference between when, I don't understand what rebase is. It sounds like it's the same sort of thing, like if I'm on master and I create a branch, and then something changes on master and I do a git whole master, it like auto merges with my branch, right? Because it goes with that whole from that. Isn't that the same kind of thing that rebasing is doing? Or?
So you're on another branch, right? That was originally checked out from master. When you do git pull, it will update master. But then on your other branch, you have to explicitly say git rebase master in order to merge those changes in that were in master.
I often see when I pull master, it automatically puts those changes into the branch that is branch from master.
No.
Are you checked out with master locally?
I have master locally, and then I branch from master locally, made some changes in there, and then somebody else has made some changes to master on the remote, and then I do git pull master, and it auto merges to the branch that I'm looking.
Yeah, that's true. You would have to switch back to master locally for the changes from master. So if you're on a branch and you do git pull master, it's going to pull master into your branch,
right.
not into master. Not into your master.
Oh, exactly.
Correct. So when you pull into the branch you're on, you would have to switch back to master, then you another git pull master.
Oh, okay, that's it. So if I'm on my branch that has come from master and I do git pull master, is that effectively doing the same thing as rebase?
Well, yeah, it pulls the changes. It does that part of it, and then yeah, effectively, yeah. Yes.
Can you talk a little bit about the difference between, like, if everybody's using the same remote repository, how is Git not a centralized system? How is it mainstream?
So it's a hybrid. It's a bit of a hybrid, but you're still distributed in the sense that you have the entire project in your hands. And you know, if you're in a bunker and the world gets destroyed, you still have that.
So in a true centralized system, people, like, whatever they're working on locally is just a sliver.
Yes, exactly. It's just the last, it's whatever they're working on, but not really they can't really go back unless they talk to the central server. Okay, I think someone else needs to set up in this room, so.